Hey, what's up, everybody, and welcome back to Code Interpret. What is a programming language, and why is it important for us to understand the core concepts of it? So, the thing is that it kind of feels like it's a really easy topic, and it's something that you can just skip for now and you can step back into it, sometime later. But I feel like if you really want to make your journey as exciting and understand whatever it is that you're learning in programming and how a program is actually executed, it makes your journey more exciting, and it helps you develop more curiosity, because if you keep having the curiosity, it would basically make you develop the motivation to learn more and dive deeper. But what happens is that sometimes people lose interest, right? And the one of the main reasons why people lose interest is because they don't understand certain concepts, and they thought that since this concept is probably, it seems easy, so maybe we could step back into it sometime later, and then things start becoming more and more complex, right? So uh, if you understand these concepts today, your entire journey of learning would become really really exciting. And so let's dive right in. Okay, some of the concepts that we're going to be learning. First, key point is what is a programming language? A machine language versus natural languages, translators, types of translators, and types of programming languages. And while we do this, we're going to come across some of the some essential keywords, and that's good to know, especially when you start to understand what's happening in the underlying part of the program. It just develops more and more curiosity for you to probably dive deeper and learn more about it. Okay. All right. First thing is a language. A programming language is a way to communicate with a computer. But the catch is that the programming language that we're writing is not the computer language. The computer language itself is a different kind of language. So the programming language that we write is human readable, and it's something that we understand. So and someone created it for us, right? So we can write a language that we understand, and we can debug or read and write. Okay, so it's a set of instructions that we provide to the computer so the computer can understand what task to perform. But there is something in between that that helps translate our programming language into a language that computer understands. Okay, now the principles of any programming language has four concepts: alphabetical. So any programming language we use or we learn obviously has alphabetical characters. Okay, so it's like Roman or A to Z characters, symbols that we use, and different types of characters. Now lexical, that's lexical. What that means is that every programming language has a dictionary of its own. Okay, so for example, in Python, we learned print. The print function, there is a certain way of writing and executing that print function, right? So if it's spelled wrong, it won't recognize it. And it's also case sensitive. So if any one of the letters are capital, it won't recognize it, right? And so that's what the dictionary is. There's certain keywords that are reserved for Python to understand, and we need to know how to use them and when to use them. So that's the dictionary. Syntactic rules. These are kind of rules that they're like principles and rules that we need to follow while we're writing a program. So for example, if we if we write a print function, we know that a print function starts with a small letter, ends with a small letter, and then followed by parentheses. And then we know that it could take as n number of arguments. Okay, and then there's a thing called positional arguments as well as keyword arguments. I've done a video about that, and you can check it out. Um, so so the rule is that when you write print, it should be followed by a parenthesis, and within the parenthesis you can put in any kind of data type you want, or you can use variables as well, and those are all positional arguments. If you want to use a keyword argument, okay, like the end keyword, then you need to use that after you're done using the positional arguments. So this is basically us following the rules. Semantic is your program needs to make sense. Okay. So if it's syntactically correct, it's but if it doesn't make sense, then it won't execute. It would raise an error. Like a print function, if you're trying to execute or write a string statement inside the parentheses, it should be within a quotation mark, right? If you try to use alphabets with numbers or integers, and you miss out the quotation marks, that wouldn't make sense to Python when you're running it. When you're trying to run or execute the file, it would raise an error, right? Similarly, if you define a variable after executing it, if you try to execute or print a variable that was defined after the print statement, it would again raise an error. What I'm doing over here is that I'm trying to print a variable that is defined after the print function, so it doesn't make any sense, right? And therefore it's saying that f is not defined. Okay, but if I swap it and then run the code again, it makes sense to Python, and it would reveal the output on the terminal and would say it's 100. Okay. Okay, now the things that so there are different types of languages. We have programming languages. We just went through that. So there are different types of languages: programming languages, natural languages, and machine language. Now, natural languages is the first thing that we understand. We generally understand when we talk about languages, we know the word we're talking about, how people communicate with each other, and they use a certain language to talk to each other or to write emails or uh, to read a book. So that all of that comes under the category of natural languages. And the machine language is basically a bunch of zeros and ones. It's a set of instruction that we write is translated into binary code, and the binary code is basically 1 and 0, and that is the core language that the computer understands, the machine understands. The machine does not understand what print is, so we need so there are translators in between that translate whatever we write in the programming language of your choice. The translator translates that language into machine language, which is binary code, and the smallest unit of data that is stored in machine language is a bit. Okay, and that's what do you call, either one or a zero. Let's try and distinguish between the differences between the three languages in the next slide. So we have translators. So the things that you must have seen, how head of states of different countries, when they meet, if they don't speak a common language, and they have a translator in between, right? So this is exactly what happens when when we write a program, which is a source code. So whatever. So if we're writing a program using Python programming language, you're basically generating a script, and that script is called a source code. It's just a file that contains a lot of text, and a task of the translator is to translate that text into something that the machine understands, and the only thing that machine understands is zeros and ones. Okay. Okay, now there are different types of translators. We have compilers as well as interpreters. Both of these are actually programs. These are underlying programs. So you know how we use a text editor to create a Python source code, and then when we're done writing the source code, uh, we run the code by typing the Python keyword followed by the name of the file with its extension on the terminal, and then when we press enter, that is when the compiler steps in. The compiler in Python converts the code into bytecode. Okay, so Python is actually considered an interpreter language. Okay, but it too also contains a compilers. Compilers are there in every programming language. Almost every programming language has compilers. Okay, and these both of these are programs, but they function differently. Okay, so let's take an example of Python. What happens is that it reads the code line by line, all right, and it generates a bytecode. So what generates the bytecode? Not the interpreter. The compiler program generates the bytecode, and then the interpreter reads it line by line, and the interpreter translates it into the machine code, which is the binary code, and that's what helps the computer understand the instructions to execute. All right, it generates a .pyc file. So you remember how we create a Python file and it has a .py format? When you run a compiler, it generates a file which is called a bytecode, and it's in the form of and it's in the format of .pyc. Okay, and it's portable. The reason why it's portable is that you can migrate that file, you can send that file to anybody and run it in any other computer as long as that computer has a Python compiler. Okay, now the role of the interpreter is to read it line by line. So once the bytecode is produced, the interpreter is a second program that reads the bytecode line by line during runtime and during execution. That's when it starts reading and starts generating an output on the terminal. Okay. And compiler languages, what they do is that they read the entire program. Okay. And they generate a file called the machine code. All right. Which is, in this case, in interpreter languages, a machine code is not generated. Here in compilers, we have machine code generated. Machine codes are faster in execution. They take longer to compile, but they're faster in execution. Okay, and they're not portable. Okay, so it says over here in point number 5, platform specific. A .exe file generated on Windows cannot be executed on Linux or Mac. You will have to recompile it again. So if you've generated a file on Windows and you're trying to run the same file on Linux or another operating system, you'll have to recompile the source code in that operating system. So it could generate a .exe file which is compatible to the configuration and the architecture of that operating system. So different operating systems have different architectures. Okay, now let's understand this visually. All right, so this is your source code, and it looks pretty much the same, right? We You have a def keyword and a function, then the return keyword. Okay, if statements and everything. This is your source code. Once you've developed your source code, what you do is that you open up your terminal, write Python followed by the name of the file to execute it, and then you press enter. The minute you press enter, the compiler takes that code and compiles it into a machine code, which is also known as object code. Okay. Now this doesn't happen in Python. Okay, because in Python the compiler produces a, b- a byte code, all right, which is an intermediary kind of file. It's a, which is a which is a file that is further translated or interpreted by an interpreter. Okay, but languages like C or C++, they compile the code into an object code, which is directly a .exe file, which is a machine code directly. Okay, and then you can use that file. All you gotta do, how do you use a .exe file? You just double click it and it starts running. It executes based upon whatever the instructions were provided to it. Okay, now let's have a look at the difference over here. So if you have a text editor like VS Code, you would use that to produce or develop your source code. Okay, and then the minute when you open up your terminal and type Python followed by the name of the file and you press enter, that is when the compiler starts working. Okay, the compiler produces a bytecode, and then the interpreter, which is also another program that which is an underlying program of Python, it reads and executes the bytecode line by line. It reads each line, checks it, and then executes it. And what is this? So this is the interpreter uses a thing called Python virtual machine. It's a virtual machine that uses the hardware and some components of the operating system to be able to execute the bytecode. Okay, so the interpreter cannot work without the operating system parts, well, components. All right. Similarly, compilers, what happens in compilers, languages like C, if you're using a text editor like VS Code, you produce your source code, and then the minute you run this on your terminal, the compiler would produce a machine code directly, which is the language of the machine. And then you can use that .exe file to execute directly using the operating system. The final output of the instructions is always executed by the operating system. Like, the operating system helps to produce the output and display it on the screen, right? So that's why this is the final component, whether you're using interpreters or compilers in both cases. Okay. Okay, so this is the last part, which is the different types of programming languages. We have high level programming languages versus low level programming language. So essentially, high level programming languages have to have a translator that could translate the code into machine code so the computer can perform the task or execute the set of instructions, whereas most of the low level programming languages produces the final machine code directly, and that machine code doesn't require any kind of translator for further translation. So low level programming languages take a longer time to optimize based upon the hardware and configuration, and so they take a longer time to produce the compiled version, which is the machine code, but it's really fast in execution, right? And high level programming languages depend on the resources or hardware configuration of your computer, which seems like it's fast because it reads. So for example, Python executes while it reads each line by line, each set of instruction line by line, right? And the interpreter, while it's reading a line, it reads it, it checks it, and then it executes it, and it keeps doing that until it reaches an error. Whereas a low-level programming language, because it has compilers that produce a machine code directly, if there is a single error in the entire file, it would it won't execute, it won't run. You'll have to debug the code and then run the compiler all over again. Whereas high level languages are quite friendly that way. Essentially, high level programming languages have translators because but the machine and the computer doesn't understand what it is. But it's a lot easier for us to learn and write that code. So therefore, we mostly use high-level programming languages on um, when building applications, right? So some of the points are like interpreted languages mostly can be slow depending on the hardware configuration used for application development and web apps. Human readable, and these are the examples: Python, Java, JavaScript, C++, and C Sharp. Now, here close to machine code, it is close to machine code or it is machine code directly. Compiled to machine code directly, faster, used for hardware programming and operating system development. It's assembly language or machine code or C. These are examples. Okay. My final key takeaway is that you don't have to memorize what programming language falls under which category. You would is eventually you would learn at least most of these names and you would understand what they are. But the important part is to understand these concepts and the types of programming languages we have, and terms like natural languages and machine code, and what's happening under the hood, right? So it becomes really exciting, and now why. So when I started programming as a beginner, like I couldn't understand the relationship between a terminal and the source code, and how and what's happening at the back end, and what the compiler is doing, and what's so when you memorize the steps, you kind of tend to lose interest if you don't understand the fundamentals. So I personally feel that it's good to know the fundamentals at the very beginning, just before you start learning programming and before you dive deeper. So you should know all of these concepts. It's really important. And if you have any questions or would like to contribute, please comment below and let me know about your feedback. All right. All right. Thank you.